Hey boys and girls, today we're going to talk about physical and chemical changes. So matter can either go through a physical or a chemical change. And there are very specific differences in those. All right. So changes in matter, that can be two different types, either physical or chemical. So you can see in the picture, they give the example of ice and water. So when this block of ice melts, that is a physical change because it's still water. It was that solid water and now it's liquid, so it has not changed chemically. Now you can see the chemical change happening right there where they're adding and that's becoming a new substance. So let's keep looking here. All right. Physical changes in matter. A physical change is when matter changes its property but not its chemical nature. The substance is still the same. So I always say, but is it still water? And in this case, is it still sugar? Yes, it's just in a different form. All right. Sorry, it's giving me a hard time. Chemical changes is when matter becomes something completely new. So just like we said with the ice and when it melted, but it was still water. Okay, this is not the same. This is new matter being formed when we are burning that wood. Okay, so again, physical changes. It's no new substance has come. We are still, like I said, water. It didn't change the type of matter that it is made of. Now, it might change the shape, the size, or some other physical property, something that you see. And many times in physical changes, you can reverse those. Now, it might not look exactly like it did before, and you can't always reverse it, but many times you can. So, although some properties like shape and phase of the material change, the material itself is the same before and after the change. Still water. So let's look at some examples. Folding paper. When we fold paper, it is still paper. Doesn't matter. You might have changed the shape of it, but it's still paper. Okay, like we said about ice melting. If we break this glass, it does not look the same, but it is still glass. This man happily chopping wood. It's still wood. The wood looks different, but it's still wood. When you break the pencil, it's still a pencil, okay? It looks a little different. So that's those physical changes. And so like we were saying, you can oftentimes reverse it. Now, the broken pencil, the broken glass, the broken wood, it's never going to look exactly like it did, but you could put it back together. All right, so here are some more examples. Aluminum foil cut in half. And you have these examples in your notes. Clay molded into a new shape. It's still clay. Okay, that butter melting on warm toast. It's still butter. Water evaporates, like we've seen so much when we've been talking about the water cycle. It's still water. Water vapor, right? When juice freezes or when rubbing alcohol evaporates, again, it is still, that rubbing alcohol is still there. It just evaporated. So you can have a physical change like a change in shape, a change in texture, change in size. Maybe it dissolves, breaks apart, in a mixture that doesn't cause a reaction. Okay, so we're going to talk more about dissolving because you might think, well, if it dissolved, it's definitely changed. We're going to talk about that in a minute. Okay, so words you're going to see for physical changes: cutting, tearing, breaking, crushing, bending, folding, warming, cooling, melting, freezing, evaporating, condensing, mixing, separating, boiling, dissolving. A lot of these can be reversed, right? If you have a can and you crush it, it's still a can. If you fold that paper, it's still paper. right? If you bend your straw, it's still a straw. All right? So you see changes in states. These are physical changes to liquid, solid, and gas. We've talked so much about evaporation, condensation. And we've realized and we've seen that, that liquid water is still water. It's just in vapor form. Okay? So we also see mixtures and solutions that are physical changes. So that's just combining two or more substances. It's still keeping its properties, like you see here. A fruit salad or cereal with milk, you can still separate those. Okay, you still have your strawberries and your kiwi, you still have your milk and your cereal. Solution is when something is dissolving, like if you did put sugar into water, or making lemonade. Those are still physical changes. It's not easy to reverse it, right? But you still have your water, you still have your lemons. They're just in a different form when they're in that solution. Seems to disappear, but it's not. And sometimes you can separate by boiling to separate that back. The water would evaporate and you'd be left with the sugar. Okay, so now moving on to chemical changes. This is a change in which one or more new types of matter form. So it is changing. That, we've been saying with physical, but it's still paper, but it's still a can, but it's still a pencil. And in this case, we wouldn't say that if it's gone through a chemical change. So these substances react and they combine and form new substances, other substances. It's not lost, it's just changed to a different type of matter. Just like we already saw, that new matter is formed, okay? That wood that is being burned is not like it was before. Okay, so here are some more examples. We see a change in color. That's a sign of a chemical change. Like when our tomato turns red, or cake gets brown in the oven, or our egg is frying, right? Think about that kind of stuff. We can't reverse that. It smells different, a different odor when you're burning those wood, when the food is spoiling, when you've let that we do a lot at my house. We don't eat all of our cuties, our little oranges, and they'll turn brown, and that makes a bad stink. That is a chemical change. Changes temperature without being heated or cooled, okay? So leaves in a compost pile, they get warm because they're rotting. They're going through that chemical change. Another sign is seeing bubbles, like when you do, like what we saw at the very beginning of this PowerPoint. When you're mixing vinegar and baking soda and different experiments, those are chemical changes because you are making a new substance. If it gives off gas or gases like burning, and a new solid, this one you see used as an example for chemical changes a lot, is rust. You leave your bicycle outside and it starts to rust, or you may have we have a lot of old wood buildings around here where we had so much farming. You'll see those nails that were put in those buildings are rusted. Okay, so when you have chemical changes, the substances present at the beginning are not present at the end. There's something new, and it can't be undone like we could so easily unfold the paper and put the glass back together like we had talked about with physical changes. Okay, so again, the matter is different. The old matter is no longer present. The original matter can't be removed, like when a new substance is formed, like rust. Okay, so here are some more examples for you. When your milk goes sour, you ever had that happen? Nice and chunky milk. Nobody likes chunky milk. That is a chemical change. When your jewelry becomes tarnished, bread, you've changed it to toast. And it's that heating up part of that. That's why that's chemical. Rust forms, gasoline ignited or lit like a fire. Hydrogen peroxide bubbles, a match is lit. Your body digests food, right? That does not look the same going in as it does going out. fruit decomposing and rotting. So here are some more examples for you to look at. We've kind of talked about pretty much all of these things. It's very important to remember physical change. Usually you can reverse it. Same properties, paper, still paper. Some key words, melting, boiling, dissolving, cutting, breaking. So here's some more examples. When you melt your M&Ms in the car, they're still M&Ms. Puddles freezing. Dog getting a haircut, making hot chocolate, powdering milk. Irreversible. Burning, cooking, baking, molding, rotting, rusting, decomposing, causing some type of reaction, seeing bubbles. We see that a lot on questions. So if you strike a match, remember any of that heat, that temperature change, when your bread molds, food digesting in your stomach. So we're going to look at these and we're going to say, is this chemical or physical? Slicing bread. That would be physical, still bread. Lighting a match. I see that fire. That helps me know chemical. Roasting marshmallows. Again, chemical. I cannot reverse that. We're heating it up. Frying eggs. Again, chemical. We're cooking them. Toast. We just talked about that. Chemical. Cracking an egg. Physical. Digesting your food. Chemical. Fireworks. Definitely that heat. Fire. Chemical. Baking a cake. Also chemical. I can't reverse that. Fresh lemonade. That would be physical. That's that mixture. Boiling your water. Again, physical. That water has become water vapor. Mowing the grass. We're just cutting it. Still grass. Physical. All right. So those are some examples. We're going to keep talking this week about physical and chemical changes. And that is it.